everyone, today we're going to talk about using algebra to evaluate limits of functions at selected points. Get ready to unlock the power of math together. Let's dive right in. The first technique is to try direct substitution. Now, if this method happens to result in a denominator that is equal to 0, then we'll use a different technique. So the first thing we always want to do is try to use direct substitution. So we're just going to take whatever our value is and substitute that in for all of our x's. So you have negative 2 to the 4th, and then 2 again, 2 squared, and then 2 times 2. So you've got negative 2 and 16. We have 3 and 8. 4 and then 4. So our 4's are going to cancel out to 0. So here we're going to get negative 32 plus 24, which then simplifies to negative 8. Here in our second question, we're going to take our negative 3. And don't forget that we want to make sure that we use our parentheses, especially when we're squaring, just so we don't forget. So you've got 9 and 1 over negative 5, and then you've got 10 over negative 5, which simplifies to negative 2. So here we use substitution to evaluate each limit. So next question, we're going to take 3 and then 2, square root of 1, which we know equals to 1, so we're still good here. All right, here we have the square root of 3 minus 5. We know that this gets us the square root of negative 2. The square root of negative 2 is not defined. So when we're looking at a limit, we say that the limit does not exist. All right, here we have 1 squared minus 1 and then 1 minus 0. This is going to get us 0 over 0, which is the resulting fraction of what is described as the indeterminate form. And so when you have indeterminate form, that means that there is a hole in the graph, which is technically a removable discontinuity, or a vertical asymptote, which is an infinite discontinuity. Now, when we have direct substitution and we see that it's not possible, another technique that we can try to evaluate our limit is to go ahead and factor. So again, this is the same question which we know got us to 0 over 0, which is our indeterminate form. So what we're going to do is we're going to take our limit at x approaches 1, and we're going to go ahead and factor. So you can factor out the numerator. That is a difference of perfect squares, and then you have the x minus 1 that is in the denominator. So you're going to notice that your x minus 1's will cancel. So limit as x approaches 1, you're going to get at x plus 1. So what we're going to do is now we're going to go ahead and substitute our 1. So you have 1 plus 1, which is going to equal 2. Okay, so here we go. We're going to go ahead first. Always try to substitute in. So you have 3 minus 3 over, let's plug in 3 cubed, 7, and then 21. So now we're going to go, let's see, we've got 0 over, you got 27 minus 27 plus, or minus 21 plus 21. You're going to get 0 over 0. So this is our indeterminate form. So we will try to factor. So you have the limit as x approaches 3. You have x minus 3. For our denominator, you can do factor by grouping. So again, you could use your box if you'd like. Right, you have x cubed minus 3x squared minus 7x plus 21. So we're going to get, let's see, x squared minus 7x and then minus 3. So what happens is our x minus 3's will cancel. So what we're going to have is the limit as x approaches 3. You got 1 over x squared minus 7. So now what you can do is you can substitute that 3. So you are going to have 1 minus, that's 9 minus 7, which is 2. So you got 1/2. All right, so here we go. Again, let's go ahead and take that 6 and substitute in for our x's. You've got, let's see, 36, 12, 24 over 0, 0 over 0. Okay, so indeterminate form. So the limit as x approaches 6, we're going to go ahead and factor. So you can get x plus 4, x minus 6 over x minus 6. Our x minus 6's will cross out. So you are left with x plus 4. Go ahead and substitute. So you have 6 plus 4, which is equal to 10. All right, here we go again. So you have -1, so 2 times -1. You have -1. All right, so we're going to have a -2 plus 2 over 1 minus 4 plus 3, which gets us 0 over 0. Again, let's factor. So you're going to have GCF of 2. And then denominator, let's see, you got x plus 3, x plus 1, x plus cross out. Then limit as x approaches -1 is 2 over x plus 3. We're going to take 2 over -1 plus 3, which will get us 2 over 2, which will get you 1. Okay, so there is also another kind of undefined situation. So when you have a non-zero number divided by 0, that indicates a vertical asymptote. So you need to know that the limit does not exist at that particular value. So if we were to, again, let's say substitute, you have 3 plus 5 over 3 minus 3. You're going to get 8 over 0. So here, not defined, so the limit does not exist. And then you have, let's see, 1 over 2 minus 2 squared, which we know is 1 over 0, which again, we know that the limit does not exist at that value. Thanks for learning with me today, unlocking the power of math one problem at a time. Don't forget to like and subscribe for future notifications on pre-calc videos. See you in the next lesson.